Okay, 8.3, we're going to start off by graphing complex numbers. If you need a review on what a complex number is, you need to click on the link that is in Canvas and go back and review. Mainly for this section, you need to recognize that our complex numbers are in the form a plus bi, where a is the real part and b is the imaginary part. Not the I part, just the B part. All right, so if we're graphing a complex number, we're going to use a real axis for the real part, and then we're going to use the imaginary axis for the imaginary part, just like we use the x-axis and the y-axis when we're graphing an ordered pair. If we're graphing a complex number, we're going to have a real axis and an imaginary axis. That should say axis, not part. Okay, so for example, if I give you 5 plus 2i, right? So 5 is the real part, 2 is the imaginary part. So I would go over 5 on the real part, up 2 on the imaginary part, and I would plot that complex number right there. Now, it actually takes it a step further because it wants to know the modulus of these complex numbers. Now, the modulus of the complex number is just the absolute value. What does that mean? You know what absolute value means. It's the distance from the origin. All right, so my origin is 0, 0. So if I'm looking for the distance from that complex number to the origin, think about what we could do here. We've got our horizontal value, that was my real part, or the a part, and then my vertical distance, I went up 2 units on the imaginary axis. That's my imaginary part. Well, how would I get this hypotenuse? Well, I've got a right triangle. I've got 2 sides of the right triangle, so we're just going to use the Pythagorean theorem. So we know that this hypotenuse squared equals a squared plus b squared, or this hypotenuse is the square root of a squared plus b squared. All right, so we're going to use that to find the modulus. So the modulus is just the distance from the origin to that complex number. So if I'm looking for the modulus in this first one that I graphed, 5 plus 2i, right? A was 5, B was 2. So I know that the modulus is going to be a squared plus b squared, or 25 plus 4, which is the square root of 29. All right, so let's do another one of those. And I was going to do them all on the same set of axes, but I think I'm going to need to do it on a separate one. Okay, so let's do 7 minus 3i. So 7 minus 3i, 7 is the real part. 1, 2, 3, 4, 5, 6, 7. Negative 3 is the imaginary part. So I'm going to the right 7 and down 3. And there is the complex number. I've plotted it. To find the modulus, that's the absolute value of z. That's going to be the square root of a squared plus b squared, which in this case is going to be the square root of 49 plus 9, or the square root of 58. All right, let's do one more of those. So this last one, I've got negative square root 2 plus square root 2i all over 2. All right, now this is not in a plus bi form, so that's the first thing you need to do. To write it in a plus bi form, just split it up. right? You're dividing by a monomial, so you can split these into two fractions. So I've got the negative square root 2 over 2 plus the square root of 2 over 2i. All right, so if I'm graphing this, and plug in the square root of 2 over 2 if you need to approximate it to see where you're going with it on your real axis and your imaginary axis. So I'm going to let this be, let's do 1. So this is 1, this is negative 1. All right, so square root of 2 over 2, if I plug that in my calculator, so it's about 0.7, blah, blah, blah. So we're just going to approximate. So I'm going negative square root 2 on my real axis, and I'm going positive square root 2 on my imaginary axis. So that is going to be about right there. All right, if I'm looking for the modulus, that's going to be a squared plus b squared all right, so let's do this. We've got negative square root 2 squared, so that's going to be positive 2 over the denominator, which is 2 squared, or 4, plus, same thing, because when I do that, I get square root of 1/2 plus 1/2, which is the square root of 1, which is 1.